Good morning. This is Dr. Henry, and it is before school here at Williamsport High. And I'm going to make a little video or tutorial to try to maybe give you some help with going from Ionic names to Ionic formulas. And it seems like every time I make a video, I'm getting a cold or something. So I'm a little hoarse this morning, but we'll see what we can do. I'll try not to be too annoying, but I am a high school teacher, so that may be kind of hard. So you need to be able, if you're given a name, right, to convert that to a formula. So let's go through some examples and let's look at this, and let me try to give you a hand on this. So let's say you were given gallium sulfide. All right. And then first of all, sorry, I was thinking there for a second. I went silent. First of all, you need to know that gallium is a metal. All right, so let's look at this periodic table. So remember, there is a zigzag line that starts above aluminum, and I thought I could write on this, but I can't. And everything, basically, aluminum, germanium, antimony, polonium, everything to the left of that is a metal. Everything to the right of that is a non-metal. So gallium's a metal. Now, when you get the name, the first thing you need to do is you get your ion sheet and you look and you write down the positive ion. So gallium is Ga plus 3. The next thing you do is you look for your negative ion. And you know this is a negative ion because it ends in IDE. So sulfide is a sulfur atom that has gained 2 electrons and it's turned into an ion. So you look on your ion sheet, and sulfide has a charge of -2. Now, there are a couple different ways you can think about this. So look, the charges have to add up to 0. So 3 minus 2 is plus 1. So we have more positive than negative. So we know we're going to have to get another negative ion. So let's add another sulfide. So now we have -4 and plus 3. 3 minus 4 is -1. That's not 0. Now we have more negative than positive. So we need another gallium, because whatever's left over is going to attract an ion of the opposite charge. So now we have 6 minus 4. So we're at plus 2. So we need another negative ion. And then at this point, we have plus 6, right? This is -6. 6 minus 6, that's not a very good 0, and everything went kind of crazy. 6 minus 6, oops, that's another bad. 6 minus 6 is 0. So this is the lowest ratio of positive to negative ions. So to get our formula, what do we have? We have 2 galliums, so we have a subscript of 2. We have 1, 2, 3 sulfide ions, so we have a subscript of 3. The other way to think about this, right, we have gallium and sulfide, is to just go, all right, what's the smallest common multiple of 3 and 2? What's the smallest number that both 3 and 2 will divide into and give you a whole number answer? Well, 2 won't go into 3 evenly, or to give you a whole number. What about 4? So we think about 4. Well, 4 divided by 3 won't give you a whole number. 4 divided by 2 is 2. 5 doesn't work. The smallest common multiple between 3 and 2 is 6. So we want a plus 6 and we want a -6, because 6 minus 6 will give us 0. So how many galliums do we need to get to 6? Well, gallium is plus 3. So we need 2 galliums. That will give us plus 6. we need -6 and sulfide is -2. So what times 2 will give us 6? That's going to be 3. That'll give us -6, and that will equal 0. And then, right, we have this giant mess here. We got to write the formula all nice and pretty. So the final formula only has the formula of the ion and the subscript, like this. So here is our final formula for gallium sulfide. Now, anything that's +3 and -2, anything that's +2 and -3, the smallest common multiple is always going to be 6. So this is a way to do it that's a little faster than writing out the ions. But you need to do whatever you need to do to get the correct answer. And once you get used to this in enough practice, you'll just kind of realize, oh, +3, -2, I'm going to need 2 galliums, 3 sulfides. Let's look at another example. Strontium oxide. So strontium, the symbol for strontium is Sr. It's a alkaline earth metal. It's got 2 valence electrons. It will lose those, so it will form an ion with a charge of +2. We have oxide is O. It's got 6 valence electrons, so when it forms an ion, it will gain 2 to get to 8. So it is -2. So let's look at this. We got 1 strontium, 1 oxide. Does that add up to 0? Yeah, 2 minus 2 is 0. So we just need 1 of each of these ions. So here's our formula. Remember, final formula, the subscripts of 1 aren't written. All right? That looks like Shro. I don't know what Shro is. And this should be a capital. Oh, I made that a little small. Let's say we had, sodium chloride. This is regular table salt. So sodium is Na+1. Chloride is Cl -1. So 1 minus 1 is 0. So the smallest ratio is just 1 to 1. We need 1 sodium. We need 1 chloride. Right? So here's our formula. Very simple. Let's look at aluminum. Phosphide. Right? We got Al +3. Phosphide is -3. So, +3, -3. 3 minus 3 equals 0. So look, all we need is 1 aluminum and 1 phosphide. Here's our formula. So basically what you can see, if you have equal but opposite charges, like +1, -1, just drop the charges and write the symbols together. If we have +2, -2, same thing. Drop the charges, write them together. +3, -3, drop the charges, write them together. So if they have opposite charges, it's pretty easy to write the formula. Or it's not as difficult. You don't have to do as much thinking. All right, this video has gotten to about 8.5 minutes, a little over. So I'm going to stop this and make a part 2.